And today we're going to be learning about tornadoes, which is super exciting. So, do you see right there? That's a tornado. So, let's first think of the question, what is a tornado? So, has anyone ever experienced a tornado? No? Yeah, neither have I. It's not very common over here.
I know a lot about it.
You know a lot about it?
Yeah, because I've learned it in school and I've seen videos.
Oh.
Like what about what they are from my teacher's brain pop.
Oh, so you're going to be an expert on this one. This is super exciting. Okay, so what do tornadoes typically look like?
They look like a big gray cloud, like it's
A big gray funnel.
Yes.
A funnel.
Yeah.
You guys are all three correct. It is just a big gray funnel, like the one we can see on a screen. And look at all the cow, the car, all flying in a tornado. So what do you think they feel like if they're just a big gray cloud? Any ideas? So I think I would feel a lot of wind coming towards me because they seem to be moving really fast. What do you guys think you would feel?
I'd feel strong wind and dust because if it's strong, it can like go into the ground and make dust.
Yeah, that is very true. The wind is very strong.
I
Feel it sucking in.
Yes, you feel you sucking it in.
think I'll feel lots and lots of wind.
Yes, lots and lots of wind. All very correct.
Big gusts of wind.
Yes, big gusts of wind. So, do you guys know anything about how tornadoes occur? No, it's okay if you don't know. Okay, so this is going to be a little confusing, but here's the definition of a tornado. It's a mobile, destructive vortex of violently rotating winds having the appearance of a funnel-shaped cloud and advancing beneath a large storm system. So, let's take apart that definition because it was very confusing, and let's use some vocabulary terms we have. So our first vocabulary term is vortex, which is a mass of whirling fluid or air, basically, and a funnel cloud, which is a cone-shaped cloud. So putting that back into the definition we just had, it's basically saying a tornado is a mass of whirling air in a cone-shaped formation that forms under a huge storm. Does that make sense to everyone? Anyone have any questions? No? Okay. Let's move on to more about tornadoes. So, tornadoes usually occur in the middle of the U.S., known in an area called Tornado Alley. They occur when it's dry or cold air meets the warm air in large thunderstorms, which we were talking about before, the thunderstorms that form at the top and where the tornadoes come out from. And they're called supercells, which is another vocabulary term. So, the U.S. has the most tornadoes per year of any other place in the world because it averages around 100 tornadoes per year. That is crazy, and that is so many tornadoes. Okay, so I know it says it on the slide, but what are some warning signs that you think come from tornadoes? So some warning signs that we know of is there's a very dark sky because that's when the supercell, which is the big storm that is on the top of this sky, is forming. And then there's also large hail. Do you guys know what hail is?
Yeah, I do.
Big chunks of ice.
Yes, big chunks of ice falling from the sky. It's like rain, but it's not rain. And there's also a loud roar, so just a very, very loud sound. Like thunderstorms, you know how they have very loud sounds? Tornadoes are very, very loud as well. And there's a lot of dark, low clouds. And the clouds are low because of the supercell, which is just the ginormous storm that is on the top of the sky, basically. So after a tornado, what do you think tornadoes do? Like, what happens after them?
Like throw everything they had like out or something.
Yes.
Everything will be damaged.
Yes, a lot of things will become damaged because it just will destroy tons of trees, buildings, everything in its path. It basically just takes it out. And this will affect the food chain because it will be killing a bunch of animals in that area. So it will put a disbalance towards the food chain, which is also very, very bad. And there's also tons of debris everywhere. Do you guys know what debris is?
Trash.
Yes. So it's basically trash that was in the sky from the storm, and it's just random like chunks of wood from houses, wheels from car. It could be anything. Debris is just random. And this could also lead to water contamination, which is also super bad. So during a tornado, we already talked about how there's going to be loud noise. What do you think you should do during a tornado to stay safe?
Go underground, like a bunker, like a bunker under the ground. That's the safest thing to do.
Yes. Why do you think that is the safest thing to do?
Because the tornado can't take you if you're under the ground.
Yes, the thing can't take you. And there's another reason that it's super safe to be underground. What do you think is flying around in the air?
Things like there could be like a building, and if it drops on you, you could get badly hurt.
Yes, there's a bunch of debris flying all over the air. So if any of that falls on you, that could be very damaging. So I am going to explain a real world example of a very, very deadly and scary tornado. So it was one of the deadliest in history. It's named the Tri-State tornado. Do you know why it's called Tri-State?
Because it was the.
You know what tri means? It's a
It covers 3 states.
Yes, good job, Dylan. It covers 3 states, so it's called the Tri-State tornado. So it passed over Missouri, Illinois, and Indiana. Those are the 3 states. And so that's over 300 miles the tornado traveled. That is crazy. And it killed 695 people. That is a lot of people. So I'm going to read a little excerpt from a story that is about this tornado. And it's a person's first-person account. Do you guys know what a first-person account is? So it's when someone is saying the story, and it's from the person who was actually there during the tornado. It's not someone who is like looking at the history of the tornado. They were there present in the event, and that is a first-person account. So at 1 p.m., a column of twisting air materialized near the town of Ellington, Montana, killing a local farmer traveling 72 miles per hour. Do you guys know how fast that is? That is crazy, crazy fast. Imagine a car going 72 miles per hour. That is crazy. It took 14 minutes and it hit Annapolis, where it killed 4 more people and destroyed 90% of their town. An hour later, the tornado spun off adjacent funnels before it mowed through Behel, which is another town. It reformed into a single system a few miles later while making its way across the rolling farmland towards Mississippi River. The tornado left Missouri and had traveled 80 miles through mainly rural farmland and killed 11 to 13 people in 83 minutes. That is a lot of people in a short amount of time. And then it traveled to Illinois. At 2:26 p.m., the storm approached the town of Gorham, throwing a golf ball-sized hail that's this big, very, very big hail. As it advanced, there was a great roar, recalled Judith Cox in the St. Louis Post-Dispatch 2 days later, like a train, but many, many times louder. My God, I cried. It's a cyclone, and it's here. The air was full of everything: boards, branches of trees, garments, pans, stoves, all churning around together. Do you know what all those are a category of? All the stuff in the sky during a tornado? We were just talking about it. Then remember the word? It starts with a D.
Destroy?
Destroy, but what's
Debris.
Yeah, perfect. Okay. So it collapsed buildings and took down restaurants. And a restaurant cook was even crushed. And another person was able to pull themselves out of the restaurant rubble, which is crazy. The tornado killed 37 people in a 500 resident town. So that means there's only 500 people living in the town and 37 of them died because of this tornado. That is a lot of people. But next was a 12,000 person town on the hit list. So Wallace Akin, a retired tornado scientist from Drake University in Iowa, was 2 years old when the tornado closed in on Murfreesboro home. An invading army of debris swept over the western hill. Trees, boards, fences, roofs. Day becomes night. Do you know why day becomes night? Why do you think that is?
Because of the dark gray clouds.
The dark
Clouds.
right?
But so floors were getting ripped off, walls were getting ripped off, and his house just took flight into the air. So that's why you can't go in your house during a tornado, because your house could just fall apart. Okay, so are you guys excited for our first activity? So you're going to be making a tornado in a jar, which is going to be super, super exciting. So has anyone ever seen a tornado? It doesn't have to be in person, like anywhere on television and books. You ever read about a tornado?
I've read books and I've seen
Yeah, kind of.
I read about tornadoes before.
I've read and seen videos.
So I've seen a TV show, a movie. Have you guys ever seen The Wizard of Oz?
No.
No? Okay, you should definitely watch The Wizard of Oz. It's all based on a tornado. It's a
I think I've seen a little bit of it.
little bit of it. Very good movie.
I think my brothers watched it. I don't know.
You guys should definitely watch. Very good. Okay, so you're going to learn about how tornadoes work, and you're going to learn a little physics behind it, which is super cool. So do you guys have the materials, or are you going to need to go get them? You have them? Okay, so I want everyone to double check. They have a jar with the lid on it that can be closed. So for this experiment, we're going to need that jar with the closed lid on it. We're going to need some water. We're going to need some dish detergent, white vinegar, and then if you want, you can put in plastic figurines, animals, dolls, anything you want. So I'm going to give you guys a little bit to go get all your materials, make sure everything's ready before we start the experiment. And while we're waiting, I want everyone just to make sure their jar is filled 2/3.
You wait, I need to get my jar.
Yeah, I will wait.
2/3.
So while we do that, make sure everyone fills their jar 2/3 full of water. And come back. Okay. Perfect. Ready for the next step? So this is optional, but we're gonna put in some dish detergent. Oh, I love the thumbs up. Into your container. So it's gonna be about 2 teaspoons, and you do not have to measure. It's just gonna be approximate. So we're just gonna pour a little bit of dish detergent in there. And so my turned slightly green because my dish detergent is green. And if you have white vinegar, you can also pour a little white vinegar into there, but you don't have to have both. And if you have any cool small little objects you want to put in, like figurines or dolls, you can also put those in there. And if you have any, I would love to see them because I don't have any cool figurines and dolls, and I would love to see your guys's. So, while we're waiting, can anyone predict what you think we're gonna do? Do you know what a prediction is?
Take it around so it'll swirl around like a tornado.
Very, very good prediction. Anyone else have any other predictions? No. Well, we can see if Dylan's prediction is correct when we do the next steps of the experiment. So, while we're waiting, I'll go to the next slide because the next slide is just putting your lid on. So, when you put your lid on, you want to make sure your lid is super, super, super secure, okay? Because we want to make sure no water can come out of this lid. So you want to crank it as hard as possible to make sure that no water can come out of your lid. Here? Perfect. Okay. Now, we're going to hold the jar with both hands like this, and you want to make sure one hand's over here because I know your top's secure, but we just want to make sure. And then we're going to shake it in a circular motion, and then you can watch as a tornado appears and fizzles away. So you want to shake it really hard, and then a cloud tornado will start to appear, and you'll see how when it starts going upward, it slowly descends back into the sky, which is like our supercell is up here. And it's, if you have dish soap in it, it's
killing.
It's okay. China is here.
this. I see a little tornado.
It's dripping.
Oh, it's dripping. So another way to get a tornado is if you just shake it like this, really hard, and then you'll see kind of a little tornado on one. I want to see if you can see it on mine. So you see mine? If I shake it like that, you can barely see it, but you can see a little tornado, and then it goes super fast, straight back up to the top. So you want to make sure you're doing it in circular motions because tornadoes are circular. Okay, has everyone seen a tornado? You guys look like you're having fun shaking the jar.
Okay, yeah, I've seen like 3 times.
Oh my gosh, you've seen so many.
Different sizes.
They're all different sizes. Has everyone seen their tornadoes? Okay. So we are going to talk about what we just saw, because we all saw tornadoes, correct?
I never saw a funnel. I just saw something spinning in there. Anything
Did you shake your jar like this or in circular motions? Try shaking it, holding it from the top really, really hard, and then you'll slowly see it's very, very faint, especially the more you do it, because then the more the dish detergent bubbles, so then it's harder to see it. But
Yeah, but if your toy is moving, that means there's a tornado because my blue thing is moving in circles.
ooh, what toy did you put in yours?
I just put a bottle cap.
Oh, that's cool. Okay, so let's debrief. So Dylan made a prediction, and he was obviously correct. That is what we did for the experiment. So what did we observe in the experiment? What happened to the dolls, the animals? What happened? Do you guys know what observe means? Yeah? Okay, so what did you observe? Basically, like, what did you see in the experiment? Anyone can unmute.
The things that we put in, they spun around.
Yes. Continue. Yes, so all the figurines, they just spun around. What kind of shape were they making when they spun? Did they spin in a square shape?
A circle.
Yes, they spun in a circular shape. So we saw, do you remember our vocab word from all the way in the beginning, vortex? You guys, Does anyone remember what vortex means?
Water or air spinning around.
Yes. So we created a vortex with our dish detergent and water. That's super, super cool. Okay, so we're gonna be moving to our 10-minute break. Okay, so we're gonna make a DIY barometer. So do you guys know what air pressure is?
The pressure air puts on people.
Yeah. Okay. So air pressure is the weight of the air molecules that are pressing down on Earth. So, what do you think high air pressure is?
Like the air pressure is pushing on us a lot.
Yeah, so when there is a greater weight of molecules, then what does low air pressure mean?
It has very low pressure.
Yeah, there's a lesser amount of molecules that are pressing down. Okay, so so air pressure is important because it can help us predict weather. So if there's high air pressure, which means there's a lot of molecules pushing down, the weather's usually calm. But if there's low air pressure, many different kinds of weathers can happen, including tornadoes. So, how do tornadoes and air pressure connect? So, a change in a pocket of air pressure leads to movement. And this movement can cause tornadoes because it's movement in the air. And as we said, a vortex is swirling air. So, what do you think a barometer measures?
The air pressure?
Yes. And with that air pressure, what do you think we can predict from it? As we just said in the last slide, what can you tell from air pressure?
How much it could, how the weather?
Yes, we can tell the weather, and that's what barometers are used for. So we're going to be starting our second activity. For this activity, you're going to need a glass jar. It does not need a lid. A balloon or plastic wrap, just something to cover the jar with. A straw, paper, scissors, glue, markers, and if you're using plastic wrap, a rubber band. So, let's start. First, you're just gonna put the plastic wrap or the balloon on top of it. So, let me show you what I did. I used a plastic bag, and I have a jar right here, and I just put my plastic bag on top of it, and then I put a rubber band to make sure that this is very taut, meaning that I can't really put that much pressure into it, so it's tight. So I want everyone to complete this first step. Okay, so the next thing we're gonna do is on a piece of paper, we're gonna draw an arrow like this. So you wanna make sure the bottom part of your arrow is thick enough so then you can stick it into your straw. Because the next step is we're gonna cut out the arrow like this, and then you're gonna stick it in to the end of your straw to make something that looks like that, okay? So let's start by drawing the arrow and then cutting it out. So then you get a little piece of paper that has an arrow on it. And then you can stick that just straight into your straw. And then once you have these two pieces of equipment, put your thumbs up, okay? Are you guys ready for the next step? So, you wanna make sure you have a super straight straw, so if it bends, just cut that part off. So you only have the straight part of the straw, and you're gonna stick your little arrow bottom end into the straw. So you get this. And once you've completed that, you're gonna use a little bit of glue And you're gonna glue it right to the center, the end of the straw, right to the center like this. So let me do that. And then I want everyone to let me know when they have finished gluing their barometer together. Done? Okay, perfect. Okay, so if you're done, you can make a background. So you can just get a piece of paper, or I just used a little food box and then I taped a piece of paper, or you can just tape a piece of paper to the wall. And you see on my little paper, I have something called high and low. And that is if I sit this on a surface and I sit my barometer on a surface, the little arrow will point right to the middle line that I drew. So if you want to do that, and because of this, then you can test out the air pressure. So you can just leave this, and if the air pressure becomes greater, what will happen is the little plastic will be pressed in from all the molecules, because the molecules will have a heavier weight, and that will force this to point up towards high. But if the air pressure is less, it will start to become little balloon shaped and it'll like blow up, and so then that will force this to point down to low. So you can have fun testing that out this weekend and playing with different air pressures and different temperatures. So let's think of some discussion questions, because we are almost done. So what is your guys' barometers reading right now? Mine's just straight across. Is yours guys straight across too?
Yes.
Yeah? A lot of them will probably just be straight across because it's pretty normal air pressure. Okay. So I kind of explained this, but do any of you guys know why it points below the midline to show low air pressure? You remember what I said? Something about there's less amount of molecules, so the thing gets a little bigger, it inflates, forcing the thing to point, the straw to point down. So, how?
I don't get what you're saying.
Oh, you don't get what I'm saying? What are you confused about?
So like, how does it work? It's not really doing anything.
Well, it's not going to do anything right now because your air pressure in your room is not going to change. But as you move it to different parts of your house, different areas outside, the air pressure might slightly change, and that might slightly make the barometer change.